Hello, for the class, we will talk about the domain modeling this time for our CSCI 359 system analysis and design. When we talk about the domain side, we'll talk about things in our problem domain, and then we'll talk about the ER diagram, the entity and relationship, and the domain model class diagram, also the state machine diagram. So we need to identify object behavior. Okay, so far we will know, we will know what's the concept of things in the problem domain, also define the requirements, identify and analyze the data entities and the domain classes needed in the system. Also interpret and create an ER diagram, and also the domain model class diagram. Then we move on, we need to know the domain model class diagram for the RMO, consolidated sales and market system. Here's one of the example, and also the machine diagram for the model object behavior. So we can move on this. Okay, so far for the problem domains, we need to know right here we will talk about the problem domain. We need to have a specific area of the user business that is within the scope of new system. And also the things that can be including all the items that works when they include all the tasks that need to be remember. Example of things can be some products, some sales, whatever, anything included. So also those things are modeled as a domain classes or data entities. So we will call them domain. Okay, so as a beginning for the problem domain, we have two techniques for identifying that. So first one is the brainstorm techniques. Just use a checklist of all the usual types of things typically found in, and then brainstorm to identify the domain classes of each type. And then we have the noun technique. So identify all the nouns that comes up when the system is described, and determine if there is domain class attributes that we need to remember. So basically for these two. So when we talk about the brainstorm, so everyone should know the brainstorm. So we start from the beginning. So we have start with things. So are there any tangible things? For example, what's the airplane, bird, vehicles, document, worksheet, or this one? So are there any organizational units, size, location, and are they instance or event that need to be reordered? And also what are the possible devices? So all these what are the role plays? So that means what the possible users. Okay. So all this we can use the brainstorm. This example. So first step, we need to identify a user or set of use case. That's all we learn. What's the possible use case? We have different actors. So using the noun verb, and then setting the boundary for it. Okay. So for the brainstorm with the user to identify the things involved when they carry out the use case, there's the things about which information should be captured by the system. And then the third one, we need to use the type of things, different type of categories too. Systematically ask a sick question about potential things, such as the following, are there tangible things, you store information about, are there any location involved, are there any role played by people that you need to remember? So all these questions. And continue to work with all types of users and stakeholders to explain the brainstorming and merge the result, enumerate any case, and then compile an initial list. So this is all the 5 steps we need to do. And then for the noun techniques, okay, for this one, the noun technique identify the problem domain class things by finding. So we need to finding, classifying, and refining a list of a noun that comes in discussion documents, like popular technique, systematic. Okay. Those end up with long lists and many nouns that are not things that need to be stored by the system, and difficulty of identifying synonyms and things that are really attributes. and good place to start when there's no user available to help brainstorm. So here's the key called the none technique. So for the step one, we need to use the use case, enter or other information about the system, including input, output, identify all the nonce. From what we talked about, like the RMO, the CSMS, the system, the nonce might be equal like customer, product item, sales, confirmation, transaction scoop, shipping, bank, changing. So all these are possible, all the nonce including. And use other information from existing system like current procedures and like current reports or forms or items or category. So right here, it can be like including the price, size, color, style, season, inventory, quantity, payment method, all this. So it can be used. They just put all the nouns. And then in the third step, as this list nouns builds, refine it and ask this question about each noun to help you decide whether you should include it. Okay, so this is a unique things the system need to know, or like is it inside the scope of system I am working on? Just like ask this question. So ask this question to decide to execute it. Okay, is it really a synonym for something, same other things? Or like also really just an output of a system produced from other information? Or is it really just an input that the result in the recording some other information have? So make sure to exclude something we do not need. And then ask this question to researcher, okay, is it likely to be specific pieces of information about something I have identified, or is it something I may need if assumption change? And then we move on about the fourth, create a master list of nouns identified, and then note whether each one should be included, excluded, or researched further. Okay, so just like mainly just really make a master list and review the list with like the users, stakeholder, team members, and then define the list in the domain. Okay, so that's one what we need to do. And then we'll keep moving on right here. So here's a partial list of the nouns for the RMO. So you will see that I identify nouns example right here. So accounting and back order information, bank, catalog activity. So all these nouns we put, and then we put a note on including nouns like what we exactly know. Okay, we know who they are, no need to store it, and then a special type of order or value or order status research. So put all this. So it's called noun. Okay. And then about the details of a domain class. So attributes describe one piece of the information about each instance of class. Customer has a first name, last name, phone number, identifier or key. So one attribute you need the identifies an instance of class, and requires for the data entirety optional for domain class, and custom ID identify will be a custom. Okay. Compound of attributes. So two or more attributes combined into a structure to simplify the model. Let's say the address rather than including the number, street, city, state, zip number, zip code like this. Some of them we combine as one, or let's make separate. Sometimes it can be also identified. Yeah, or the key is a component attributes. Okay. If you look at this, okay, a class is a type of things, and objects is specific instance of class. Each instance has their own value for attribute. So right here is okay, all the customer has this, right? Customer ID, first name, last name, home, phone number, work number, and also they have some value right here. Okay. So actually, if you learn database, then you will have a pretty understanding of this information. Okay. And association, like among the things, obviously association and naturally occurring relations between classes. So we have some, let's say we have after the user, it works somewhere where they work. So they have called accounting department, and then it's an order is placed by who, and it's contain maybe the size, location, and then we have contains like genes like this. So all the information. And then just need to classify. Okay, call the association on the class diagram in the UML, like multiplicity is the term, the number associated between a class. If you remember in our previous class, we drawing the the class diagram. So talk about the relationship, like one-to-one, one-to-many, many-to-many, all this. And also we'll talk about this, about the multiplicity. And also when we call the relationship and the database, we have the cardinality. So this is pretty common, we talk about it. So all these we will represent like involve like possible minimum maximum. So association and the relationship apply in two directions, with them separated each way, and then customer place an order, and then order is placed by the customer. So how we look at it. And we have the minimum and maximum multiplicity. So associated with a minimum maximum constraint. So minimum can be 0, that means it's optional. It can be no, that means nothing. But if we have at least one, we need to put one. So that means the association are mandatory. So right here, so if you still remember the last case, like when we look at two classes, like two tables, are asking the relationship was the minimum, like should be at least one or no. So you can recall the memory, and then we will study more in the use case, like case study. Okay. And for the association, we have called the binary association. So binary association just like exactly like two different classes, and then let's say the courses session like includes the student, and then a member join the club. So it's binary or like unary association, and then it's called the recursive. That means it only between two is the same class. So let's say a person married to the person, then will be under same table, or like pass make by using pass. Let's say we in a company, we have an employee and a manager or regular employee, advisor. They all belongs to like same, maybe let's say same table, I call employee. And then if we have manager, so who are managing, so actually it's a recursive, like unary association. Ternary association with three, or ternary associate like between and multiple, but sometimes we will change it to look better. And then we talk about the ER diagram, ERD, and then it has been used in many years to develop data model, and you also use database development. And the 10 things in the models is called the data entities. So the ERD model are not UML model, but do not use the standard UML notation. The ERD model are not unlike expressive as the UML model. They do not model the generalization, specialization well, and then they are not model like whole or parts well. So like this. So the UL diagram, we all mainly look at this like cost-free notation, but this is what you learn like most in the textbook. Also the new way, we are just using one or many put right here. So we are not required to do that. So let me share change the desktop. Okay. So if you look at here, so let's say I have the 1 or 2. Like this. Okay. So if I have a customer, and I have a order. So if I want to, I'm sending a relationship like this, I can. So remember, for the relationship, we have like one. So all the order will be belongs to one customer, and then for the customer, we can have multiple orders. So it should be like one-to-many relationship. So we can just use the number in this way. So 1 and n. So for customer, we have multiple orders, and then we have for the order, we have only one belongs to one single customer. So it will be like this. Go back. They're using the cost free, but we are I do not require to do it this way. So we just using the numeric notation. So it's like, and then for the ERD cardinality symbol, so they're using this one like exactly one, mandatory 0, and more than one optional. So multiple. And when we explain that the ER diagram with like attributes, so will be you see the attributes we are encoding like for customer. So this one PK representing the like primary key, and then also when we link, we also like set the like what's the foreign key. So we have several different notation method attribute in the ERD type models. This notation places an attribute like within the data entities. It's a one way. And as a follow up right here, so like if we refer to the diagram right here, so we have multiple like representing mentally optional, and if we are drawing a chart, then I would say we just using the notation will be like this. Right here. Okay, so because we always say like it's the relationship will be one to many, but for the minimum, like for the order, we should have at least one customer to create it. So it should be like 1 to 1. So that means like for the last one, it representing the maximum. So at least we should have like belongs to one customer, and then it's possible to have no customer to order. No, it's impossible. So we should be 1 1. So if the order is possible, that okay, so it's possible we have the case like this, like 0 1. Yes, we can have the situation like this. That means like maybe we do not require to have a some query. Then it's okay. Just like, but for this case, the example like customer make an order, then we should have that the order should belong to certain customer. It's impossible we have an order, but nobody create. Okay. And for the many, so then we ask a question like, is a customer is like required to have place at least one order to become a customer, or say they can create an account, but they don't have to like make any purchase yet? If yes, then we will be 0 to many. Okay, but you say no, once they make an order, then we create an account. And there should be at least one order, then you should change to 1. So we be depends on the situation. It can be like minimum will be 0 or 1. So the first one is minimum, and second one representing is maximum. So the showing the relation. So all the combination will showing like this. Okay, and let us keep going. Okay, what's the semantic net is a graphical representation of an individual data entity and the relationship of other individual entity. It also often used to help understand and then develop the ELD diagram. Okay, so you see here's an example like showing the 3 classes. So here the class like John or the 1, 2, and then Mary is not yet, so we can see why it's a 0, and then the first, second, and then Bell, and then like this Boost, or this semantic net. So it's showing. So if I ask like semantic net, so the user information, and then we're showing like this. Okay, this is all the content. Okay, ERD. So when we draw ERD, so we will put all the customer account, the branch, and then answer transaction. So we'll put right here. And we need to know like sometimes like what's a class is the type of classification used to describe collection of object, domain class. The class describe the object in the problem domain, and then the class diagram, the UML diagram that shows the class with the attributes and association, like plus the method of the model, like a software class, and also the domain model class diagram, the class diagram that used to include only includes the classes from the problem domain, but not the software classes. So no methods. So we say that domain method, no class. And then class diagram, we also like include the method with when we have a it's like for the software. But most time we talk about the software. So but for the system design, sometimes we not really talking for the software, then we do not need to include it. Okay. And here's the UML domain class notation. So the domain class right here, like name a name and then the attributes, and then the class are always like capitalized, and then the attribute names are not capitalized. We call like this combine. Okay, Camelback notation, work one together, and second words like capitalized like this. and then compounds the class name, can use the common notation like this. So it's got domain class notation. And then a simple domain model class diagram, it would be like this. Okay, you see, like we like customer, other names, and then place, we have the word. So we are showing the relationship one, and then here will be many. So the extra, the star we also represent is many. So minimum is 0, and then order 1-to-1 relationship, and then it's like minimum at least there's a 1 order item, and also multiple order item. So this one match the semantic like shown previously. So customer places 0 or more like orders, and then order is like placed by exactly one customer, and then order consists of 1 or 2 more items. Order like is part of exactly one order. So it will be like this. So here will be shown here like the UML notation 0, 1, 1. I'm not recommend, but like this one showing 1, so I will recommend is like 1 and only 1. So they are mandatory, but actually it's representing the similar. And then 0 or more, and then 0 or more alternative. So I would recommend like either doing this one, showing the range. This one is kind of like confusing, so I'm not recommend in the middle one, and 1 or more like mandatory. And then the domain model class will be like this. So domain model class diagram. So it's a bank with multiple branches. So in previously in ERD, so just like we have also same the title, the name, and then the attributes, and then the relationship are here. And we have one more example is about course section and student. So the same, so right here. Okay, we need to, when we find the courses enrollment model with associated class right here. So when we need to modify, we see here treat as the class and many to many association, because they have attributes we need to remember. So you see the course right here. When we have many to many, we always like create one more table and change to 1 to many to like this. Okay. So we keep going. The association class is the same things as the association itself, and then the unique identifier key for the association class is the concatenation of the keys of the attribute classes. So right here we say combine here. So here's some example, and then with the like members and the concept, they will be like band 1 to, it's like 1 to many right here. So multiple band member, it belongs to one band, and then band how many concert, and then we have the band with the concert booking information. So we extend, so more for the band, they maybe have for the booking, we'll see, okay, booking date, performance orders, like base page. So add more. And when we join, we also break the line. So we when we really join, we won't like putting a line and then draw one. So I would recommend just like draw the separate one, connect them together. And we have a more complex issue about the classes like generalizations, specialization. So like hierarchical relationship where the subordinate classes was special type of subordinate classes, also they call the inheritance hierarchy. Okay, and then super classes. So there's superior or like more like general classes and generalization or specialization hierarchies, and then subclass. So there's subordinate or more like specialized class in the generalization or specialization, and then inheritance. So the concept that's the subclass inheritance, the characteristic of more like general superclass. So the generalization is like when we have like motor vehicle, more general, and then under we have maybe truck, car, or tractor. But under car, we have like sport cars, then the sport unit. So all this. Oh, here's the also it's pretty common. We have the abstract class right here. So the class allow the like subclass to inherit the characteristic, but never get the instinct. Okay. So right here, sales will be here, sales maybe sales daytime priority like tax or this. And then concrete class, when we have the in-store sales. And then we have the online sales like telephone sales. And then inheritance will be here, the attributes are online. So we would get all the same, but for the concrete, that one will be, they have their own, because they based on, they have their own attributes, but they will still inherit all the same. Right here. So here more example. So for the transaction account, and then under account we can have a saving account or like checking account. So we have an arrow to represent. So we are getting the same attributes. They will share attributes, but for the saving account we have the interest rates. But for checking, just a checking style or minimum balance. That's how it looks like. And then more complex issue about classes and whole part relationship. So whole part relationship, the relationship between classes, and where one class is a part of like components portion of the classes aggregation. So the whole part relationship where the component part exists separate and can be removed and replaced. Okay, so computer just have a hard disk devices and store the devices existing from the computer. Okay, or like the car has wheels, so wheel can be removed, but still can be a wheel. So like this. Composition, so like a whole part of relationship where the parts cannot be removed. So it will feel like in the diamond symbol, like order item on the order, without the order, there's no order item. The chip should be have a second, so we need to learn this. So we will showing like the diamond shape right here. So processor with a computer, so commercial have a processor, we have like monitor, but we don't need to really have a monitor for computer. And then main memory, so for computer we should have main memory, and then storage, also like input devices. So we will be like part of it. So all this will be part as of a, so when you see it's a composition, that will be the web diamond. So whole part can be have multiple too. So you can show it here, but it didn't. So in this part, and we keep going. Then we'll talk about more on the UML diagram, the relationships. So there are like actually 3 types of relationship in diagram. So association relationships. So there are like association discussion before, like in the ELD, and then we have the whole part relationship. So one class is a component of a part of another class. Also generalizations, but so that's the relationship inheritance. So this one, try not to like confuse the with the association. Just make sure the relationship. Okay. This one is about the example, and we will discuss in the next class. And this out for our, we'll stop at right here, and we'll study more about the case and how to use. Okay, thank you.